Okay, so this is our ALU simulation. We will start off with the first opcode, which is basically add without send case. As you can see right here, we need to set everything to 0. Once everything is set to 0, we can basically try to get an invert for CN, and we notice that there is no invert for CN, so that's fine. That's what we need. Now what we will do is we will try to add to see if we can actually get a carryout. So I'll do switch 1, 2, 3, 4, and indeed we do get a carryout, thus add without send case. Okay, for number 2 we have the add with CN case. So we can start off by saying if we add 2n, which is going to 2. So now we state that we actually have 2 in binary form. And let's say, for instance, if we wanted to add 1, we can turn switch 0 on, and that'll give us a 3. Or if we wanted to add more than that, for instance, if we wanted to add additional amount from 2, we would get an output of 4 for that amount going in, or we could basically state that we would have 6 going in because we had 4 plus the 2, and that'll give us 6. Alright, for this one we have subtraction, so for the first thing we'll do is we'll make this a 2's complement. So now everything will be -2 based off the fact that for the value of 1, it is now considered a -2. Simple demonstration of subtraction, we can basically say if we give this a value of 1, we should be able to see that there is indeed 2 minus 1, which should give us 1. Or we can always do this, where we can say 2 minus 2 will give us 0. Alright, this one's for the logic shift right. So let's say if we did switch 6 and switch 4, it's 3. As you can see, we have 2 bits right here, and now we want to shift it to the right. So therefore we can do the offset, and then we get a switch to the right. Or if we want to go back left, we can do that, and we go back left. Alright, for the number 5, which was the arithmetic shift right, all we essentially need to do is to switch the 11000 all the way to the right. So we could turn on the switch. As you can see, now we have a switch input right here over the LED light showing that indeed a switch has been moved from the left all the way to the right, indicating this light lighting up right here. So if you go from there, you can go to there. Voila. And this one will be for the arithmetic shift left. So with everything turned off, everything is set to 0, we can basically state if we put a switch 1 in the 1 position, that'll give us an inverse right here in the 0's position, and that's basically stating